Hello dear children, how are you all? Hope you all are fine and doing well. Dear children, today we are going to start a simple machines chapter. Yes, it is very simple. If not also, we are going to make it very simple. Dear children, before going to start today's class, first let us see what are those concepts which we are going to learn. Hey, hope you all are excited. Yes, dear children. First, let us know the topics, children. So, in this chapter of simple machines, we will be discussing about work, energy. Then we talk about the machines and its uses in a simple manner. How can we use the machines in our day-to-day life? Okay, once we complete the machine and the function, well, not function, just examples, we discuss about principle of machine. Then only we discuss about the efficiency, mechanical advantage, functions of machine. Hey, one more thing, types of machine. There we are going to discuss about ideal machine versus actual machine. Okay, so once we complete the machines, we discuss about the levers. Hey, it's not lever, lever. Okay, lever types. Then we discuss about the pulley. After that, we have a simple thing like a wheel and axle, inclined plane, wedge, and finally screw. So these are the simple topics which we are going to learn in a simple way in this simple machines chapter. Are you all ready? Yes. But dear children, in this single video, we are not going to complete the entire chapter. I mean, we do not rush like putting like just heading, writing something by saying that yes, chapter is complete. No, it's not our intention. Yes, we will try to make this entire chapter into 3 parts. In a simple way, in a slow manner, in a meaningful manner, in a fruitful manner, we are going to discuss. So let us see today's agenda. In today's class, what actually we are going to discuss? Yes, children. The children, in today's class, first we discuss in detail about work. Then we discuss about the energy. After completion of work energy, we are going to talk about the machines. There only it's examples. Then we'll try to understand the principle of machine, efficiency, mechanical advantage, and there only we discuss about the functions of machine, and finally types of machine, that is ideal machine versus actual machine. Clear? Okay. The children, please be ready with your notebook and pen so that you can take some important points which are going to help you a lot for your exams. Okay, children, fine. So first, let us start with the work. W-O-R-K. What is work, teaching? Of course, whenever I say this work, many of you will think and feel that, sir, daily we have so much of work, sir. If I ask you what kind of works, you will tell that so much of homework, math work, physics work, science work, project works. Dear children, whatever you are doing, is it work actually? Means, in some cases, dear children, whatever we feel it is a work actually, scientifically it may not be work. Means today, I am going to tell you, we are going to discuss what actually work is in terms of science. Scientifically, how can we define the work? Sometimes whenever we have some stress, mental stress also, we feel that yes, we have done the work. But let us try to understand what actually work in terms of science, scientifically. Okay, first suppose, dear children, if you want to move any object, first suppose here, yes, now let us say here is an object. It is there in my hand here. So from here, if I want to move from here to here, so what I have to do? I have to apply some force. So here I applied some force. Then only the body is displaced. Yes. Now I can say that yes, I have done some work. Which means what? You have to apply the force and body should be displaced in the direction of applied force. Then only we can say scientifically work is done. Yes, let us try to understand both also. First, suppose, dear children, here is that object. Okay, here is a body. Okay, so it is here at a point A. Okay, now here we are applying some force F. Okay, some force is applied. Then let us say that this body is displaced or moved, let us say, to this. It has moved to this new position. It has move to the new position. Let us name it as B. Means it has covered some distance. It has covered some displacement. Yes. Don't get confused, sir. You are using distance over displacement. So distance and displacement. Whenever a body is moving in a straight line path, we can take both are equal only. So displacement is what? The shortest length between the 2 points. So let us say, dear children, it has covered some displacement. Yes. Children, here don't get confused here. Work we will represent with the letter W, force with the F, displacement S. So now I can say that this force has done some work. Means what are the two conditions here? Force must be applied on the body and the body must be displaced. So children, come on, let us define. Work is said to be done only when a force acting on a body displaces it, or work is said to be done when a body is displaced in the direction of applied force. Clear? Fine. Now let us see mathematically how can we calculate. Dear children, mathematically work is equal to force into displacement. Force into displacement. Let us just in the symbols also we can represent. W is equal to F into S. Yes, this is a formula to calculate. Now, dear children, let us take a simple example and how can we calculate mathematically. For suppose, okay, example 1, let us take, okay, example 1. For suppose, okay, in this case only let us say that you applied 10 newtons force. We applied 10 newtons force and bodies are displaced by 2 meters, let us say that. So, how much force we applied? Children, as if we are applying force. Come on, how much force are we applying? We are applying 10 newton force and the body is displaced by 2 meters. Now what is the work done? So how can we calculate? Yes, we have formula here. Means here F is equal to, you substitute 10 newtons, displaced equal to, you can substitute 2 meters. Now let us calculate. W is equal to 10 newtons into 2 meters. 10 into 2 is how much? 20 Newton meter. So now work done is 20 Newton meter. But children, here I want to tell you an important point. This Newton meter only, we can call it as a joule. Joule, joule, not jail. Okay, it's not jail, joule. Some people can call it as even joule also. Joule. See, and the children, you know very well, whenever you are writing the full name of the unit, first letter must be a small. Symbol can be a capital. Why? Because it is a scientist's name. Okay, fine. So here, now I can write work done is 20 joules. So with this here we have learned one more point. What is that? Here joule is the SI unit of work. The children, in exam, if they'll ask you to mention the SI unit of work, you please write joule, Joule. Clear? Fine. Now let me take one more example. Okay. Now children, here let us say here is an object. Now here I am applying the force. Like this I start applying. Come on, yeah, Bahubali. Okay, I am applying the force I applied. Children, if I apply like continuously, if I apply force like this, hours, 1 hour, 2 hour, 3 hour, what happened? After some time, my energy gets exhausted and I feel that, oh my God, children, I have done so much of work, but I could not make the wall to move. Then do you agree that I did work means? No, you say that, sir, no, you have not done work. Then I may ask you, why children, I tried so much, I spent so much of energy. Then you will tell that, sir, you applied force, but wall did not get displaced. It not displaced. Yeah, you are right, children. There must be some displacement. Okay, for suppose here is a wall. Let us say that here is a person. Let us say me only. Let us say I applied 100 newtons of force. So, of course, in this case, force is equal to 100 newtons. But do you think that the wall got displaced? No. Displacement is how much? 0. Now calculate the work. So 100 into 0. So it is 0. So scientifically, dear children, if body is not getting displaced, if a body is not getting displaced, then work done is said to be zero. I think you are not able to see. Let me try to show. Yeah, let me try. Now I think you are able to see. Okay. Oh, if I'll do this much again, there will be problem. Okay, na? Clear? Okay, children, clear? Okay, fine. So now work done is how much, dear children? The work done will be zero, which means what? If force is acting, if a body is not displaced, then work done will be zero. So what are, in exam they may ask a question, then what are the two conditions to say work is done? Force must act, body should be displaced. Hope it's clear? Fine. Yes. Now let us discuss about the energy. Let us discuss about the energy. Dear children, if we have more energy, we can do more work. If you have less energy, less work we can do. Which means what here? Work and energy. Very important, children. Very important. So here, work, comma, energy or relative terms. What are those? Relative terms, children. Relative terms. Means, as I told you that your energy is talking, means if you have more energy, we are able to do more work. Less energy, less work. Means it is nothing but the capacity to do the work. Yes, dear children. So the ability or capacity to do the work, ability or we can say capacity to do the work, is called energy. Then you may get a wonder, sir, what are the units for energy? The children, work and energy both are related terms, so same units we use. So here also for energy, SI units of energy are joules only, Joule, joule. Children, for sake of your extra information, I'm telling you. So whenever I'm talking about the SI unit, you may get wonder, sir, what about the CGS units? Yes. So even for work and energy also, CGS units are ergs. Children, not egg it is. ERG. Don't make it as egg. Okay. ERG. SI unit is a joule. CGS unit is erg. Children, we have some relation between these two. 1 joule is equal to 10 power 7 erg. It's just extra information. Just keep in your mind. Okay. This relation they may not ask in exam, but it's for knowledge only. Clear? Fine. So children, this is about the work and energy. Hope you have copied. Can I raise 3, 2, 1, go. Yeah. This is about work and energy. But thing is that in our day-to-day life, what do we feel actually? We want to do more work, but we are very selfish, right? We want to apply the less energy. We want to put the less effort. We want to spend the less energy and the comfortable manner we have to do. Is it possible? Like doing more work, spending less time, spending less energy, putting less effort. Is it possible? It is possible with only one device. What is that device, children? Come on, what is that? Machine. Yeah, yes. So that is the machine. So with which we are going to what? We are going to what? We are going to become lazy. Yes or no? It's correct only now. Because the science and technology, as we are depending more and more on machines, we are becoming lazy on it somehow. So what do you do? It depends on how we will use man. For a correct purpose, if you use it's okay, you're efficient. If not, you will become lazy because depending on machines, also not that much is not accepted. Okay. So what is my suggestion is that children, maximum try not to depend on machines. Okay. Where it is really needed, you can depend. Okay, fine. So first, machine means simple thing. Few things let us try to relate with this machine. So we want to do more work. Okay. Correct. We want to do not mark, it is more. What is this, children? Going wrong. We want to do more work. Okay. Next, we want to spend less time. Okay. And less efforts. Yes. Less efforts. And we want to spend even less energy. Yes, yes, yes. For this, one device will help you. That device only, device only, machine. So, machine is a device which will make our work easy. Okay, more work only, but easy way. So it is a device which will make our work easy. Okay, now by spending less efforts, less energy, in a less time, in a comfortable manner. Such a device is called machine. Children, machine is a device which will make our work easily by spending less time, less energy, less efforts. Okay, na fine. And you may get wondered, sir. Children, can you give us some examples for machines? Come on, just pause the video, type at least one in your daily life. And children, whenever I say machine, don't imagine a complicated structure. How they'll show in a Hollywood movies, big structures, complex. No, 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 no. So those things are, it's a combination of machines. But let us talk in this chapter simple machines. For example, if you want to open some lid of any tin, we use a spoon, right? We use a spoon. That spoon is a simple machine. To cut the paper, to cut the cloth, we use a scissors. Scissor is a simple machine. To means what we can say, to insert the nail in a wall, we use a hammer. That is a simple machine. And we use a knife to cut the vegetables. It is a simple machine. And morning or the great municipality people, hats off to those people, because without that we can't clean the city. So they'll come to take out the dust and everything, garbage, they'll come with the one, what is a wheelbarrow. Wheelbarrow is a simple machine. Children, if you go on just saying like this, we have the big list, we'll get it actually. Big list actually. Okay, na? So means some other way, directly or indirectly, we will be depending on the machines and we are taking their help so as to complete our work easily by spending less time, less energy with a less efforts. So these are the few examples for a machine. Okay, now if you want to understand the principle of machine, efficiency and mechanical energy, few technical terms are very important. Technical terms, okay. Children, in our ICSE board, they are very particular about the technical terms. Now look at here. For suppose teacher, let me tell you. This is my machine. Let us say some machine. Okay. Children, if you want to make the machine to work, you should operate it. Still machine only, but still it is in our hand, children. We have to operate. Means to make the machine to work, we should apply some force. For example, wheelbarrow is a machine only. Okay, na? Easily you can carry the heavy weights, but still you have to push it. Means you are applying some force. Let's say this is that wheelbarrow. Let's say the wheelbarrow only. You can take any machine. Just M can be any machine. So to make the machine to work, first we should apply some force. Do you agree? Do you agree? Yes, children. So on this machine, we should apply some force. Children, the force applied on the machine by us technically is called effort. It is force only, but one technical term we are giving. What is that, children? Effort. Okay. Now this force is nothing but called effort. So in exam they may ask a question. What is effort? The force which is applied by us on the machine. Why are we applying the force on the machine? To make it work. To make it work. Is the point clear? Yes, that is called effort. Now for suppose the children, here some load is there. Some, or not what we can say, some object is there. Object is there. Let us say some object. Some object. So our intention is, it is a heavy one. Heavy object, let us say. Heavy object. We want to lift it. We want to lift it. For that, first we applied the force on the machine. Now our job is done. Now, machine has to apply some force on the object to lift it. Yes or no? Yes. Let us say, children, here. Now here, yes. Machine is applying some force. Machine is up. Children, here two forces are there. We are applying some force on the machine. As a result, machine is applying force on the object to lift. And children, the very important thing is that then how much force is needed? Yes, it must be equal to the weight of the object. Minimum force required. The minimum force required by the machine to lift the object is equal to its weight. For example, it's 100 newtons, it must be 100 newtons. If it is 500 newtons, it must be 500 newtons. If it is 1000 newtons, it must be 1000 newtons. Okay, is the point clear? C means this is actually load. So this force must be equal to this load. That's what for this term we gave as a load. It is a load. Are you able to see first? Let me check. Yes, you are able to see. So children, here now two terms we got here. One is a force, one is the effort, one is a load. So what is effort? The force which we are applying on the machine to make it to do work is called effort. What is the load? As a result, machine is applying some force to lift this object. That force only we can term it as a load, which is equal to the weight of this object. So effort and a load. So we can use what we can say, some symbols also. E for effort, L for load. Like this you learned in LQG. A for apple, B for ball, C for cat. Like that here. E for effort, L for load. Don't say M for machines. It is not in the textbook. Just I said casually. Okay, fine. And children, so here we are applying force on the machine. Means what? We are doing some work on the machine. Why? To make the machine to do work. So if you want to machine to work, you should do some work on the machine. Yes, children. So the work what we are doing on the machine is called work input. Very important. Means we should do some work, children. Work input. So the symbol we can use WIN. What is work input, children? The work what we are doing on the machine is a work input. As a result, work does some work on the load, right? Machine does the work as a result. That work done only we can call it as a work output. Work output. So this we can say OUT, work output. Yes, children, let us recall the terms. What is effort? The force which is applied by us on the machine is called effort. And what is load? The force applied by the machine on the what we can say on the objects is called actual load. What is the work input? The work what we are doing on the machine is a work input. And what is the work output? The work done by the machine on the objects is called work input. And the children, here whenever we are choosing the machines, we'll talk about the efficiency. Will it work properly or not? Till what extent it will work? Will it work up to the mark? And what base we decide is a good machine or not? Based on its efficiency. Then you make it on. Sir, how can we calculate the efficiency? Yes, before going to calculate the efficiency, let us discuss about the principle of machine. Children, very important for examination point of view. Principle of machine. Principle of machine. Children, in ideal condition, see, first we expect like this I do, like that machine will work. Same thing is happening, right? Your parents, how they'll think? Your parents think that, yes, I will send my child to the school. Then in a decent way, we'll listen the class. Honestly, he'll do the work. He listen to the classes. He does the work. He gets a good marks, good rank. But children, are these things are happening 100%? Of course, you are trying to put your sincere efforts on it. Are these things are happening 100%? No, it's ideal. The ideal conditions, parents and the teachers, we also expect like this we are doing, like this students should do, like that. That is what actually ideal condition only. In between, some distraction will be there. Your friends may disturb, some sounds may disturb. You may get some sleep also in between. You may feel some bore. These all are some distractions. So, though you are getting input from your teachers, from output, you may not get properly. If you get more output, more result, you are more efficient. So, like that, even for machines also, if you want to decide the efficiency of the machine, first we should talk about the work output, work input, and what base principle of machine work. What is a principle which we are taking to make the machine to work? Yes. So, according to principle of machine, children, in an ideal situation, I repeat once, in an ideal case only, in ideal case, we expect work output must be equal to work input. In a reality, it won't happen. Children, I'm only telling. In a reality, work output can never be equal to work input. Why? Some friction will be there, energy is lost to overcome the friction, many factors will be there. Okay, so what is the principle of motion, children? So principle of motion states that in ideal case, work output must be equal to work input. That's it. Okay, fine. Next term, children, efficiency. We are talking about the efficiency. So efficiency, actually in higher classes, we represent with eta letter. Eta means what here? You just write like a small letter n only. Try to pull his leg a little bit. That's it. Efficiency. How can you define efficiency? It is defined as the ratio of work output to the work input. So in symbols is equal to work output by work input. So the ratio of work means how much work we are getting as output. That if we divide it by with the work input what we are doing, then you will get the efficiency. But children, efficiency usually will express in terms of percentage only. So percentage means how can we write like this? Efficiency percentage means work output by work input into 100. So if you multiply this ratio with 100, you get an answer in terms of percentage. Okay, children. So this is what actually efficiency. Just efficiency. Whether it is a less than 1, more than 1, more than... Now we are not discussing. Just how to calculate the efficiency. Just divide the work output with the work input. That will get. That's it. Okay, fine. And here, one more important term which we have to discuss. Children, please, I'm following this order like this, like this, like this. So accordingly, you can copy. Okay. So next, mechanical advantage. Mechanical advantage. I think I need a space to explain in detail about mechanical advantage. Children, can I erase this part? 3, 2, 1. Okay, yeah. Because in textbook in mechanical advantage, it is given less than 1, greater than 1, equal to 1. Some students are not understanding. So I want to give you detailed explanation for that. So let me take this space. So it is mechanical advantage. So we can represent with the MA. Hey, MA means not Master of Arts. Master of Architect, not that actually. MA, mechanical advantage. Capital letters. Okay. So children, it is defined as the ratio of load and effort. Very, very, very important. So mechanical advantage. If you want to calculate the mechanical advantage of any machine, what do you have to do? Yes, you substitute here load value and substitute the effort value. That's it. A shortcut you can write MA is equal to here L by E. So mechanical advantage is equal to load by effort. Children, did you notice one thing? Even efficiency also, work output by work input, which means what? Work by work. You will get the value but no units. Why? Work output, joules only will measure. Work input also measure in joules only. Both will get cancelled. So I forgot to tell you that. Please excuse me. So efficiency has no units. Similarly, mechanical advantage also, look at it. Load by effort. See, load also force only. Effort also force only. Force units by force units. Newton by Newton. Both will get cancelled. So children, mechanical advantage has no units. Mechanical advantage has no units. Why? Because it is a ratio between the same two physical quantities. Now children, let us see. Let us take a 3 situations. For example, dear children, if load is 100 newtons, okay na? And we are applying effort as a 20 newton, then calculate the mechanical advantage. In exam they may ask a question. Okay, yeah, look at here. So here, oh, not ME, extremely sorry, MA it is. Yeah. So mechanical advantage is equal to load by effort. Load is equal to 100. Effort is 20. So 21s are 25s are. So here I got mechanical advantage as 5. Okay, very simple. If load is equal to, okay, load is equal to, let us say, some 50 Newton, and effort is equal to some what you can say 100 Newton. It can be. We'll discuss in detail later. In even a higher class also we'll be learning. Just possibility. So children, I'm taking just arbitrary values to make you to understand. If what happens. So here now in this case, let us calculate mechanical advantage. Mechanical advantage is equal. Children, come on, you do it. Pause the video. Comment your answer. What is the mechanical advantage in this case? Come on. 3, 2, 1, go. Come on. You can do it. Come on. You can put your efforts. Okay. Hope you have done. Yes. Come on. So load by effort, that is 50 by 100. 51s and 52s. So that is 1 by 2. Chill, 1 by 2 is what? 0.5. So here we got mechanical advantage as 5. Mechanical advantage as 0.5. Now if load is equal to some 40 Newton, effort also 40 Newton only. Effort also 40 Newton. Then what is the mechanical advantage? So 40 by 40. So equal to 1. Equal to, children, with these conclusions, hey, I think you are thinking that I am teaching you numericals, right? No. I am not teaching numericals here actually. It's not, don't think it's a numerical. We are going to have a wonderful conclusion about the mechanical advantage. What is it, sir? You may get on. Yes. So here in this case, mechanical advantage is equal to 1. You may say, yes, sir, correct. Here it is a 0.5. 0.5 children, can I say mechanical advantage? 0.5 is less than 1, right? Yes. It can be less than 1. Yes, correct. Here mechanical advantage 5. 5 means greater than 1. Okay. So here mechanical advantage is greater than 1. Yes, dear children. So for a mechanical advantage, these three what we can situations are possible. Means mechanical advantage can be greater than 1, can be less than 1, can be equal to 1. Children, such a wonderful conclusion. Wonderful conclusion. So if a mechanical advantage is greater than 1, that particular machine acts as a force multiplier. Acts as a force multiplier. Means what? As I told you, for what we can say wheelbarrow case, we apply less effort only, but it is multiplied so many times. So machine with the mechanical advantage greater than 1, force multiplier. It increases the force. Machine with a less than 1, it acts like a speed multiplier. Means it increases the speed. Just symbol like that only. It increases the speed. Then you make it one doubt. Sir, mechanical advantage equal to 1 means it neither acts as a force multiplier nor acts as a speed multiplier. Then you make it a one doubt. Sir, it is not acting like a force multiplier. It is not acting like a speed multiplier. Then what is the purpose? Purpose is that to change the direction of effort applied. We discuss in detail, don't worry. When we are discussing the functions of machine, we'll discuss all these things. Okay then. Machine with mechanical equal to 1, it is used to change the direction of effort applied. To change the direction of the effort applied. That's it. With this, we have done the mechanical advantage concept. Children, mechanical advantage concept, not machines chapter. Don't be excited. Okay. Copy this. 3, 2, 1. Okay. Can I erase? 3, 2, 1, go? Yeah. Yes, children. Now we are going to discuss about the types of machine. There we are going to talk about the ideal machine and actual machine. Before that, just let us recall these two terms now. Efficiency is equal to work output by work input, and a mechanical advantage is equal to load by effort. Children, These are very important. Okay, fine. First, let us talk about the ideal machine. Ideal machine means what kind of machine we can call it as ideal machine. Children, you may get one doubt, sir, are these kind of ideal machines possible? Possible, but only in dreams. Reality, it is not possible. Okay, now fine. So first of all, ideal machine. So what is the specialty of the ideal machine means? In the case of ideal machine, dear children, remember that work output is always equal to work input. Work output is always equal to work means this numerator equal to denominator, both will get cancelled, means 1. Efficiency is 1. 1 in terms of percentage, 100. Children, if efficiency is 100% means, oh my god, in dreams it is possible. Okay, na? So for ideal machine, work output equal to work input. So whenever work output is equal to work input, dear children, both are equal. So efficiency is equal to 1 or 100%. You may get a one doubt, sir. Is it possible to have work output equal to work input? It is possible only when no energy loss. No energy loss. Again, you may get a doubt, sir. Is it possible to have a zero energy loss? It is possible only when we have no friction. There is no friction at all. Then with this you can understand. Come on, sir. Without friction, no chance. That's what I'm saying. It is possible only in dreams. Okay, na? It is possible only because energy should not get wasted. Further, there won't be any friction. And moreover, machine should not have any weight also. Oh my god, this is highly impossible. Without weight, is it possible to have some body? Not at all. I mean, in G0, that is different case I'm talking. In our day-to-day life I'm talking. Okay, na? So these are the few properties or a few points related to the ideal machine. Now let us see actual machine now. Actual machine. So actual machine. So let us see, even we are seeing the, it's like ideal machine versus actual machine. Okay, yes. So for this actual machine, dear children, work output can never be equal to the work input. Can never be equal. Doesn't mean that work output can be greater. No. Sorry. I mean, work output is always less than work input. Work output is always less than. So work output is what is a numerator. So if the numerator is always greater than denominator, then it can never be equal to 1. Greater than to, no chance at all. Equal to, no chance at all. So efficiency of the machine is always less than 1 or less than 100%. Less than 100%. So as efficiency is not 100% means always there is some energy lost. Energy is lost. Some energy loss will be there. Why? Presence of friction. Presence of friction. That's it. Not friction, sorry. Friction. So children, these are the some important points related to the ideal machine and actual machine. And the functions of machine actually that has to be learnt in detail. So as I told you that, as I promised you that I don't want to rush to explain the concepts in a single video. I mean, if video is going to be lengthy also, I feel bored, and definitely students, you also feel bored. So the functions of the machine, the levers, that concept will be discussed in next class. Okay, so let us recall once again, dear children, what we have discussed in today's class. In today's class, we discussed about the work done. What is work? So work is said to be done only when a body is displaced in the direction of operative force. So the SI unit of work is joule. What is energy, dear children? The capacity or the ability to do the work is called energy, and its units also same like units of work only. Then we discussed about the machine. So machine is a device which makes our work easier means by spending less time, less energy, less efforts. And then we discussed some examples of machine also. Then we discussed the principle of machine and the important efficiency. What is efficiency, dear children? The ratio of work output to the work input is called efficiency. Next, mechanical advantage. Mechanical advantage is the ratio of load and effort. But the very important point is that mechanical advantage can be greater than 1, can be less than 1, can be equal to 1. And finally, we could discuss the points are ideal machine and actual machine, the things are. Okay, na? So next class, I think very soon, see, this is the first video for class 6 students. So many parents, of course, are well-wishers, I can say that. That's really great to have such a wonderful parents and supportive parents to our channel, because we don't do advertisement and we don't request anyone to subscribe, like, share and all these things. Yes, of course, somehow they all are supporting. Thank you so much for all the parents and students for supporting our channel like this. Okay, so yes, this might be the first video, but I'm promising you that yes, very soon I'll be uploading the remaining parts of the machines chapter. Not only machines chapter, the children and parents, I'm going to upload complete 6th, 7th means almost 4 chapters we uploaded. I'm going to continue so that we want to support somehow to the at least few students. Our channel may be helpful to score the marks to understand the concepts. Okay, thank you so much. All the very best.